Video notes for section 4.5. Today we're going to be solving exponential and logarithmic equations. And along the way, that's going to allow us to use some of our properties and our laws that we've been talking about the 2 days prior to this. And that was the point, was to lay all that groundwork in 4.3 and 4.4, so we were ready to go to use it for what's left, which is solving and actually word problems. So there really are just kind of three types, and we're going to go through those today. The first one we're talking about is an exponential equation. I think the most variety comes in your exponential equations in terms of just like methods and how you might go about getting through the problems. There definitely is a way we want to approach each type of problem. So we're going to go through three categories today, and exponential being the starting category. You want to isolate the exponential part of the problem. That's going to require some algebra of some kind. So manipulate things till you get the exponential part alone. And now what we can do is we can use the third law to help us bring our exponent down out of its spot up in the exponent and into the equation where we can do our normal algebra kind of stuff. What allows you to do this is if it starts out as exponential and you want to get that exponent down, you have to log both sides. So the method for solving an exponential equation at some point, usually towards the end, is log both sides, bring your exponent down. Once that exponent is down, in like with our regular line of work, then we can just do our normal algebra solving to finish it up. Some of the properties to remember are the ones I have along the bottom of the screen here. So you can see the first one I call the workhorse property, which we use quite a bit in the 4.3, 4.4 sections. The natural log version of that is the ln of e to the x is x, so that's the same property with natural log. Then the one in the middle there, where x equals y, is one of the 5 properties that we discussed a couple days ago. This one is handy when we're doing a log equation and we have log on both sides. If we can get log of the same base, then we can drop our logs and set the expressions equal. That'll be one of our solving methods a little bit later on in the notes. And then just some simple things like log base 10 of 10 is 1 or log base 4 of 4 is 1. You know, some of those ideas that pop up. Also, some things to think about before we start solving is, are no solutions possible, which they are. You guys know from the last couple of days of discussion that there are some things we can't take the log of. Can't log 0, can't log negative, and natural log, same thing. So it is possible that you're solving your equations and along the way, you're at a point in the problem where you're trying to finish it up and you are trying to either take a base to an exponent and it's producing a negative or 0 result, which cannot happen, or you're trying to log negative or 0, or you get it solved, but you have to check your solutions. And you plug that x value back in and it causes 0 or negative in the log equation. All things we'll talk about, different kinds of problems as we go through the notes. But the point of this slide and me talking about these two concepts here is that it is definitely possible to get no solution. Okay, so let's just start with some basic exponential problems. We're going to be a little bit of algebra manipulation up front. When I said the first step was to isolate the exponential part, that means just the part that has an exponent. So the 10 to the 3x we have to get alone. A couple quick steps there. Now, as we do this work, what I want you guys to try to do is some of the basic algebra in your head. If you think about it, the first 2 steps are divide by 3 and subtract 1. If you divide by 3, 5/3, subtract 1, 3/3, you have 2/3. So I really don't expect you guys to show me on paper divide by 3, subtract 1. Those are algebra 1 baby steps. I don't need to see that stuff. Now I've got the exponential part of the equation isolated. And the idea then is how do I get that 3x down into the problem where I can do my typical kind of algebra work. When you go to log both sides, which is the process, you want to think about what log base do you want to take. The fact that I have a base 10 exponential means it would make sense just to log both sides because log base 10 of 10 is 1. So what I mean by that is, what's a good choice for log? Because I can log base anything I want, but I would ideally make the base match the base of my exponential. So here's what we're going to try to do. I should log base 10 of 10 to the 3x. I want those two to be the same. Because when I do that, that actually fits into one of my properties, which is this. Or also the fact that I could go about this a couple ways, drop the 3x out front, using one of my laws, right, my third law, and then say log base 10 of 10 is 1. I guess I kind of see it as I'm looking at this. So by logging both sides, and I do have to log both sides, so I'm going to do that. Log base 10 of 3x then would be 3x, and my other side would be log of 2/3. Now, one thing you guys want to get used to is log of a number is another number. If I go to my calculator and I do log of 2/3, it'll give me a decimal. So that's fine. We'll just treat that entire thing on the right-hand side like a number. The last little bit of algebra here is to divide by 3. And then for most of these problems, especially in the exponential part of the assignment, you will have to go to your calculator to finish it up. And then equals whatever I get. So there's the work of it. It's really a lot of algebra, actually. I mean, if I look at this problem, the only pre-calc step in there is log both sides. Everything else, 90% of the problem, a bunch of algebra. Now, as you go from problem to problem, it just, the approach can be a little bit different depending on, how you get the thing isolated. If I go to the example down below, what I want to get by itself is e to the 5 minus 2x. And so really, again, like 2 seconds worth of work and I'm good to go. Because it's base e, when I go to log both sides, I don't log, I ln. Because the goal here would always be log of the same base as whatever your exponential base is. So we all know that ln is log base e, so I would ln both sides. One of the things I want you guys to try to do too is, because these problems tend to have enough work as it is could you solve for x right now, no more work on paper, give me an x equals expression that would go into my calculator. If you think about the steps, when you do the ln of e to the x, or the ln of e to an exponent, you get the exponent. So that means the left-hand side is 5 minus 2x equals the ln of 3. Now, what are your steps? Algebra 1, subtract 5, divide by negative 2, go to your calculator. So what I'm saying is, let's leave out a little bit and go x equals what? Calculator. In between, there really isn't even a lot of work. The ln of e to an exponent is its exponent. That's a property. And then, okay, do you want to show me on paper, subtract 5, divide by negative 2? I don't need to see that. I don't need to see the black line either. You can go from my first kind of ln both sides piece to the red to your calculator. So you can see within the first two, I'm going to kind of reemphasize a little bit, it's an algebra problem for the most part. Now, if I go back up to this problem, there's a couple different ways to do this, so you got to kind of decide how you want to go. Do you want to log both sides? What log would you use? Do I want to change the base to be the same base, which actually would make it easier to log both sides? So as is, right now, I could log base 9 both sides. I could log base 27 both sides. Depending on which one of those I do, that gives one side of the equation looks a little bit better than the other. Or ideally, just make the bases the same before I start logging both sides. There really is nothing to isolate. In this case, it is what it is. So what I'm saying about making the bases the same, let's talk about if I didn't do that and I was trying to log both sides. Let's say I chose to go log base 9 of 9 to the x minus 6. Okay, well that's not bad. That's x minus 6. On this side, that's log base 9 of 27. Now, log base 9 of 27 is something you guys should be able to do without a calculator, because what power would 27 to the what would be, 9 to the what would be 27. And that would be 3 halves, right? Square root of 9 is 3, 3 to the third is 27. And so log base 9 of 9 to 3 halves is 3 halves. My answer is 7.5. Now I think this is kind of not the way I would go, but I'm showing you some options here. I could also log base 27. Remember, you can log base anything you want. So let's say I go log base 27 of 9 to the x minus 6 is log base 27 of 27. Well, log base 27 of 27 is 1. But now I have to deal with the other side and change my 9 to 27 to some power, and you get to be a bit of a mess. And I actually don't really like either one of these ways. The third way is for you to not log anything and just think about what you're looking at for a second. Let's change them both to base 3. So 27 is 3 to the third, 9 is 3 squared, And yes, you have the exponent of x minus 6. So now we have 3 to the 2x minus 12 equals 3 to the third. Well, if you can get the base to be the same, then essentially all you got to do is solve the exponent question. Like 2 times what minus 12 is 3. And if you're not sure about that, just do the work. So to me, of the 3 options I showed you, log base 9 both sides, log base 27 both sides, or do no logs at all, I would do no logs at all. Just realize that 9 and 27 can both be turned to base 3, and then that's less work. But you do have some options, and again, it kind of be sort of what you see. Some of you guys will see it as log both sides, and some of you guys will see it as this last version. Hopefully, the more you do, you kind of pick the more efficient way to go, which I think is this one. A few more exponentials. There's more, I think, again, more variety with exponentials, so we're going to do probably 2 to 3 times as many of these examples as we do the others, but again, because there's a lot more to show you guys. So now, base 10, base 4. What do? Do I log base 10 or do I log base 4? Does it make a difference? It doesn't make a difference at all. Actually, you can do either one. I think when I see a base 10 in the original problem, I kind of just like to do just log both sides. Because I feel like if I log base 4 of 10 on the left side, that creates more work for me. So I'm just going to LOG. And I'll show you some options too. So now, a couple things going on here. First of all, when I do log base 10 of 10, that becomes a 1. Or log base 10 of 10 to the 1 minus x is 1 minus x. That's the left side. When I log the other side, I can use the third law of logs and bring my x exponent down out front. And now, essentially, I just have to finish the solving. Solve for x. Well, what I'm about to do for solving for x, and I've said this to you guys, different chapters, and this, actually even within this chapter, is an algebra solving we already know how to do. So if I'm trying to solve for x, it would make sense to get my x's together on the same side of the equation. And how did my 2x's become 1x? Again, this is our question I've asked you guys plenty of times. Divide both sides by, and then again, I would just go to my calculator. Equals whatever. So not really that difficult, right? If I decide to log base 10, great. Now, some of you guys might say, well, why don't I log base 4? Totally fine. When you log base 4 on the left side, you're going to have log base 4 of 10. You're going to have to bring that exponent down, which is 1 minus x, and I think it just creates a little bit more of a mess of solving. So if I already have 10 as one of my 2 bases, then I think I'll just use plain log. And I'm not going to go through the other option. Just save a little bit of time on the video. If we do every version of every multiple version of every problem, this will take forever. So that's, I think, the most efficient way to go. And then that mess over there was supposed to be my approximately what? Okay, last one of this type, and we're going to do a little bit more exponential too, but isolate. Now again, what I'd like you guys to try to do on this problem is see if you can get down to e to the x equals something. No work. This would not be the solution, but it'd be like one step before we get to the solution. So e to the x, no work. Now, if you're thinking through it in your head, and I'm going to think out loud here, what are the steps? And this is the same steps and types of stuff we've been talking about since chapter 1. Algebra solving. We've got to be good at algebra solving. First step, which you all know, multiply both sides by the denominator, get rid of your fraction. What I'm actually not going to do is I'm not going to distribute the 4 in. I'm going to turn right around and divide both sides by 4. So multiply both sides by 1 minus e to the x and divide both sides by 4. What I now have is 10 fourths or 5 halves equals 1 minus e to the x. Now I'm going to subtract 1. 5 halves minus 1 is 3 halves. Then I'm going to divide by a negative. E to the x equals negative 3 halves. Now I'm not saying that you have to be able to do all this algebra in your head, but I'm saying that you should be able to do it. If I write what I said, here's what happens. Multiply both sides by the denominator. Divide both sides by 4. reduce my fraction, subtract 1. Divide both sides by a negative. But everything that's done in black, does that really need to be done on paper? I mean, again, a lot of that is just like baby steps, right? So maybe you want to do half of that because you want something. I'm saying I think you could go to e to the x equals negative 3/2, just like other days where I said you're not going to get to that if you don't know what you're doing. That's not going to happen just like out of the blue. So e to the x equals negative 3/2. Now, if you guys can get yourself to this spot, does it occur to you that's done? No solution. Because you can't raise any base to an exponent and produce a positive result. So e to the what is negative? Nothing. If you don't realize it there, then there's going to be something else that we're going to try, which is, what if you decide to go ahead and log both sides? So I would ln. ln of e to the x is x, because I'm solving for x. Okay, what's the ln of negative 3/2? No solution. You can't log a negative either. So either you realize it basically right here, hey, I can't do that exponentially, or you go on to log both sides and you realize I can't do that logarithmically either. No solution. All right, I'm going to show you the last two exponential problems. Then I'm going to stop this video. There'll be a second video to do the log equation, so we can kind of break this up a little bit. So other things that will be wrapped into exponential will be, other algebra methods and so other solving methods. You guys look at these two, and I think in a matter of seconds, hopefully your algebra brain kicks in and goes, yeah, I know what I'm doing. This is factoring. I see factoring questions here. Factoring just the way you would expect. If you guys look at this equation as an algebra 2 problem, it probably would read like, so here's the algebra 2 version of it, and we did this kind of thing in chapter 1. Can you see kind of the simpler problem sitting behind it? How I would factor this algebra 2 problem and our pre-calc problem is actually pretty much no different. That means over here I would have e to the x. So be able to see this stuff, I think is useful almost all the time. Do you see that basic problem sitting behind your more complicated problem? And not even that complicated right now. Do your normal kind of solving stuff. What I will tell you guys, the error here that most students will make is they'll stop at, like you feel like you've solved your factors because your brain is working in the algebra 2 mode. Like I'm done, but you're not because you haven't solved for x. You've got it down to e to the x. Now again, thinking about what's possible, what's not possible, that's a no right there. To solve this, you have to ln both sides. So the ln of e to the x is x. Your answer would be the ln of 2. And again, go to your calculator. So all these problems generally finish with calculation. What are you going to get? Okay, I think the factoring aspect here, pretty easy. We've done enough of this kind of stuff, other chapters, again, that you guys should be able to handle that. If you look at the bottom one, my first question is it factored by grouping? Would you know by the numbers? 3, 2, and negative 12 and 8. Well, if the second set is a multiple of the first set, probably, right? So here what I'm going to do is I'm going to take out an e to the 2x. Create that like factor, then factor that out. Then also this, if you guys think about it for a second, difference of squares, right? So again, you're not done. You've got e to the x and e to x, but that middle one is out because you can't raise base e to anything. You get a negative number. These are ln. So now what I'm going to do is start cutting out a little bit of work here and just say we should be able to go to this. And what I'm doing there is go to my calculator. And what I did from red to black was log both sides. Okay, I'm going to stop here with this video. The second video we'll pick up with all the log solving equations, but this is enough on the exponential part of it.